Mr. Esker, come on up. Hey! Thank you very much. It's great to be here with real humans in the flesh. Actually, please, the rest of the panel, we'll certainly go through in just a moment introductions, and they'll do a much better job of expressing where they've been at, where they're coming at, how they're coming at this set of problems than I. Actually, let's just go ahead and start. Vaibhav, would you mind introducing yourself?
Thought we were doing it alphabetically, but I'll go first.
So in no particular order except for seating chart, you first, please.
All right. So hi, everyone. My name is Vaibhav Kamra. I'm CTO at Kasten by Veeam. So we focus on backup, data protection, and we're going to talk about data and storage today, which is very near and dear to my heart. That's what I've done my whole career, storage, file systems, databases. This is going to be fun.
Nice. Awesome. Yeah, hello, everyone. Glad to be here. I'm Bhavin Shah. I'm a tech marketing manager with the Portworx or the Cloud Native BU at Pure Storage. I've started my career with storage, moved to compute for a while, and then came back to storage. So yeah, not a storage hardcore.
Hi, my name is Sid. I'm a Kubernetes developer. I've been working on. Lately, I've been working at MinIO as an engineer, working on object storage. I've been leading the COSI effort, which is bringing object storage to Kubernetes. Yeah, that's my introduction.
All right. Hi, everyone. My name is Michael Mattson. I'm a tech marketing engineer at the Hewlett Packard Enterprise. I've been covering storage for containers there for the last 5 years. I came in through the Nimble acquisition. So I'm part of the solutions engineering team, basically, within the leg of the organization, which is primary storage, like the Nimbles, the Primeras, the Aletras, and so forth. And I've been doing storage for the last 20 years or so.
Well, thank you. I guess I should introduce myself. So I'm Rob Esker. I'm at NetApp, sort of work in the intersection of open source, cloud, and data management. And for the last dozen or so years, in particular, around upstream and open source. And so have taken on a variety of different sort of roles, wear different hats. For example, work within the CNCF on the governing board last few years. And I guess today, as a moderator. So this is a narrow topic, storage and data management, right? So I don't know if we'll be able to fill the time up, but let's actually just start. There's no shortage of superlatives and data points, anecdotes about like the rise of importance, and I guess the notion that now Kubernetes is ready for high SLA production. And let's just start with that. What's your observation of that? Are we fully there? Is there work remaining to be done? And high SLA can be defined differently. So let me just kind of start from that end, and everyone can chime in. Not to pick on you if others have an opinion.
No, yeah. I mean, I'm an easy target, so that's fine. Yeah, I mean, we have a number of customers in oil and gas and financials and such. They run full-scale production with storage as a very centric use case, right? They try to deploy databases that they want to migrate from their legacy monoliths. They move from virtual machines and everything, right? And they just want to take advantage of the cloud-native patterns of declarative models to abstract their systems, basically, and their monolithic old applications, and also take on new technology, of course. And they all require persistent storage one way or another.
I mean, how about everyone else? I mean, is it broadly ready for all scenarios of crown jewels, critical SLA?
Yeah, I'll start. I mean, yes, I will agree. And I think everybody here on this panel will agree because, that's what we go after. That's most of the customers we deal with. They're talking to us not because they're doing proof of concepts or they want to get things running. It's because they're running production workloads. They care about their data. They care about where it lives, what storage it lives on, how it's managed. So it's definitely there. The analogy I use very often, think electric cars. It's the same thing. Electric cars are here. There's a lot more work to be done. The work is not done, but they're here and they're going to be mainstream.
I was just looking at a data on Kubernetes community session this morning, and they had a recent survey of 500 people, and 90% of those say they are ready to run stateful applications in production, and 70% of them are already doing that. So I know it's still a bubble, like we are only talking to people who are running these or care about Kubernetes, but still it's an ever increasing bubble. We are always trying to convert more and more folks on the value of containers and the value of Kubernetes, and then obviously once you do that, you bring them on board with the stateful workloads, and that's what you need to run in production, I guess.
I guess from my perspective, my background is in object storage, and I'm also leading community within the Kubernetes project. And what we're trying to do is add more to Kubernetes, things that are missing. So one of the things I would say is, to answer your question, I would first ask you, what do we define as high SLA? Now, if we say, can we run just about any workload on Kubernetes, the answer is yes. But can we do it in a cloud-native way where we can be portable across different providers, be hybrid cloud ready, or can we work with the way Kubernetes divides projects into teams and within an organization? There is a little bit work left to be done, one of which is what I'm working on. Yeah, that's what I would say.
Okay, well, thank you. I mean, some data points that I can recall. This is from last year's CNCF survey. I think it was like 92% of those surveyed indicate that they were using it in production. That was like a 300% increase over 2016. Maybe a little bit of confirmation bias in that we're surveying those who are already involved in some form of CNCF, but you can definitely sort of see the directional trend. How did we get there? I mean, CSI played a role, I guess, in the earlier days. Is CSI an active place for further evolution, or where should we focus to fill in those other gaps? If we could just talk a little bit about CSI and where to go from there.
So CSI is a standard. It's really a set of APIs to abstract file and block storage for containerized workloads. One other form of storage, which is low-hanging fruit for this question, is object storage. Object storage is one thing that still needs to be worked on.
So, but do you ever see COSI and CSI as exclusive, or do you think that comes together, or is there even a point to that?
Well, looking at just how applications are deployed, there is a need for CSI and for COSI. They're gonna coexist, just like there is a need for file system block devices and object storage.
Yeah, I think both are go hand in hand. They're both COSI is heavily influenced from the things that have worked well in CSI, so which is a great thing. But CSI is absolutely one of the reasons why we are here today and why we've had the success. We talk about community. Jing mentioned this of how CSI came about. It was not just different vendors in Kubernetes. It was different container orchestrators getting together. Dell EMC, a lot of people leading the charge there.
I know of a couple other companies.
Yeah, So CSI is absolutely one of the reasons why we're here, and it will be one of the reasons why state in production is going to be successful.
And like the community is like so active, like the number of features that they introduce, even with the 1.22 release, like a couple of things, like adding Windows support and making that CSI compatible, adding support for read-write once pod, which is something that not everyone in the community knew that it was a need, but still the community identified that and made sure it was a GA feature in the 1.22, and then just looking at their design and alpha and beta releases planned for the next couple of Kubernetes release, they have so much new stuff coming along. So again, if you are using Kubernetes, CSI is definitely the way to go.
So I'm going to state a point of view that I've heard expressed about CSI. So first of all, great work and a necessary, but in this point of view, insufficient, set of capabilities. And so, CSI, fantastic for providing a common standard abstraction to backends and a way for, in the process, standardize CRUD operations, and likewise, maybe get at the distinguishing qualities of different backend storage, because not all storage created equal. But what about the whole rest of the data management equation, like application consistency? And how do I take like the state of an application in one place and move it, rehydrate it elsewhere in its entirety. Storage and persistence is part of it, and CSI does that, but there's more to the story. And so do you see CSI as solving that problem, or is that happening elsewhere?
I think Rob from the previous panel was talking about this. What we are seeing in the industry is we're seeing more application level concerns or higher order functions such as moving data or ensuring consistency, or he was talking about snapshots earlier, happening at the application layer rather than at the infrastructure layer. So if it's more likely, I would think, or even a better architecture, I would think, for CSI to manage manage the orchestration of file systems and block devices, and less of getting into application level concerns. Now, CSI itself currently provides a snapshot API. It's also providing a way to detect failed drives and deal with it. Those are all still infrastructure level concerns. When it gets to application level concerns, it might be better to leave it to the applications because they know how to best do it.
To the individual application operators?
Right. Mm-hmm.
Does that mean you do or don't see a place for potentially an upstream, codified Kubernetes backup API?
I can probably take that one, because if it's backup, there's, just to rewind and then come back to it, I think when we've looked at, if you just look at it, what happened in Kubernetes from an architectural point of view, the idea was there's not one interface, one API to rule them all. Separate things into their own groups and then go have the experts work on that and define the APIs for that. So I think similarly, CSI is not the API to rule them all. CSI is an interface for block, file. We've got COSI for object. We will have similar things for data protection, for application, codifying applications. We have the data protection working group that's working on this exact problem where we've got all the vendors in there trying to define that API so that you can then build higher level constructs that can take advantage of these.
Cool. So I guess one of the things that comes to mind is the Kubernetes community has historically sort of provided for optionality. You sort of alluded to it just now. And I'll draw from, and I'm not even sure it was original to this space, and this is dating me, but in the OpenStack space years ago, it's still very viable for those who are deploying it. There was this notion that an OpenStack deployment was a snowflake in the sense that it was all frozen and hexagonal. But boy, they sure did look a lot different. And so, Kubernetes has massive qualities of unlocking optionality. But are those different qualities of backing storage unlocked through CSI? Are your CRDs present in all of the places? Because again, sort of some of the hype around Kubernetes is write once, run anywhere. It's a common abstraction. But not really, not unless you've provided for all of those other things. How do you think about that? Is that a strength or a weakness?
Yeah, I can talk a little bit about that because we're facing this very problem on a day-to-day basis here, right? So if we kind of look back at the evolution of persistent storage on Kubernetes, it was very simple in the beginning, like with the flex volume driver, we had like very simple primitives. And now with CSI, we have a big governance around the standards that are evolving, right? Such as the snapshots and such that we talked about. And if we look at the next kind of level of where we want to take that is that we want to be able to abstract basically the features and the characteristics of our backend storage systems. And historically, how we've done that in the past, at least at HPE, is that we allow like end users to annotate the persistent volume claims and such to perform certain operations. And we implemented our own kind of consistency groups and all that. And that is not very, very viable, right? Because at the end of the day, the end user experience is what matters, right? So if those capabilities are not available on all the different cloud providers, all the different vendors, they don't really matter, right? And that's where I see a lot of the new features that are becoming available in the CSI specification that are helping us a lot, right? Because we help customers migrate workloads from bare metal and VMs and move their persistent storage. We help the customers like clutter their PVCs with full of options, right? And that is not a very viable way to do that. So that's the volume populators feature I'm talking about in the CSI specification, where a vendor can basically dictate, use this data source reference, and that will import a volume on an existing array or an existing cloud volume, whatnot, right? And that will drive that type of standard. And another upcoming feature in CSI is the ability to move snapshots between namespaces. I know the Kasten, they will definitely benefit from that, right? And that will allow us to do a lot of advanced data management in a secure and multi-tenant way, right? And that's kind of where we want to be and standardize on.
Anyone else?
But then,
Go ahead, yeah.
Okay, going back to your point, right? CSI as a base is perfect, but then what developers do care about, or application teams do care about, is just how can I run data services, or how can I just get storage without even understanding what the backend storage is, for example. Like, CSI obviously did a great job. We have Kubernetes objects like persistent volumes and volume claims, but then talking about the build once, run anywhere story. If I have a test environment in AWS and I want to run my production on-prem or vice versa, I need that level of consistency from a storage backend perspective as well. Like, I need the same layer. So if I'm building a set of YAML files for my application, I don't really care where I'm running it against. Like, what's the API, the Kubernetes API server that I'm running it against?
Yeah, I think it's really interesting that when you say storage, we often will just gravitate to block or file or object. But a lot of times, actually, when I look and talk to people who are here and I ask them what their storage system is, it is not one of those. It's actually Postgres or Cassandra or some higher level hybrid out of that. So what storage now means to people who are building these applications is actually very different from these lower level abstractions. And so that's also where there will be standardization, there'll be APIs, the whole operator model is just amazing, and we're seeing some innovation happening.
And to add to Vaibhav's point, right? If I'm a developer, I don't really care about how do I deploy a Postgres database. I care about the connection string. So I need a layer, like as a developer, right? And again, the ops side of the house can implement different ways on how to get there. But as a developer, all I care about is I can get a connection string, I can write data, and then that data exists. Like, it doesn't go away when my pod goes down or my cluster goes down. There is a backup, there is a disaster recovery plan. So you need to think about all these different aspects around persistent storage, not just, I can write data to a persistent volume.
I guess I agree with both of you, actually. So what CSI does is moves the concerns around everyday orchestration of files and block devices. Same thing with Cozy with object storage, and allows you to focus on your application logic. Now, the job of any framework is just that. It abstracts some things away, so you might not be able to do everything you could do with a particular vendor's system, but it pushes you in the right direction, most likely in a way where you didn't even need to worry about that concern in the first place. So really, it's a strength, even though it can't do everything that say a particular vendor can do. CSI probably doesn't provide APIs for everything. Looking at the bigger picture, it's definitely a strength, because it's pushing us in the right direction.
So I'm going to take a little bit of attack. You mentioned, one of you mentioned a little bit about sort of, how you provide the infrastructure, how it exists. And, there's the notion of data services that are provided by, in a variety of different ways by hosting providers, or that may just exist elsewhere in the environment from an external team. But then there's like different flavors of connecting systems that may be under your management, perhaps via CSI, or perhaps actually seizing upon the desired state qualities of Kubernetes itself to maybe actually run your storage, your data management, your protocol stack itself for vending storage in Kubernetes proper. How do you think about that? Is that like a predestination paradox, running like storage within the cluster to provide storage to entities within the cluster? Should that exist externally? Is there a proper nesting? Should they be discrete, separate systems? I imagine there might be a few opinions.
Yeah, I can do the neutral answer here, and I think there's room for both because we sell hardware platforms mainly, right? But we have customers that are using the raw block volume functionality of our CSI driver to deploy Rook to provide additional data services that we cannot provide, right? So there's a combination there, right? So you run CFFS distributed on top of Kubernetes, as Kubernetes was designed for distributed applications, and that is a very good storage paradigm for that, right? And we can provide the raw block storage to the node, and but you still don't have that like encapsulation of your NVMe drive local in the server, right? Because that is the main headache, right? That you want to get rid of, or if there's a virtual machine attached disk, right? So there's room for both, for sure.
Yeah, I see them as two separate problems. One is abstracting the infrastructure. The other is providing a system service or abstracting an application service. Let me rephrase that. Abstracting an infrastructure service, providing storage, say, like he was mentioning, Rook, for managing some databases, or the other side of it, which is CSI, which is abstracting away provisioning of volumes, block devices, file systems, putting it into the pod, and taking care of authentication along the way.
I just feel if we trust Kubernetes to run our apps, we can also trust it to run the storage layer as well. And the same portability that we get by running applications in Kubernetes, you can get the same level of portability with the storage system as well. Like you need a storage system. Again, it depends, right? There can never be like one right answer when you're dealing with.
There's like a theme here, maybe.
Well, yeah, I'm also with Mike here. I'm neutral here because we mentioned this way up in the first talk about what's important here. What's most important is we don't lose developer agility. So what that means is let people do whatever is best for their environment. And I think, what people don't want is they don't want to be managing multiple systems to do the same thing. So if you're doing storage systems and then you're doing, more storage systems on top, in the cloud, that doesn't make sense, right? But on-prem, it does because you need the agility. So it really depends. I guess we just came back to the same answer, but we can't lose sight of what the developers want and how they're building their applications. You just can't make it complex for them.
So that, appealing or retaining the ability to appeal to need for developer agility, that optionality as a strength, that still can look a little bit like choice paralysis to those who are sort of starting in on this journey. Maybe it's as simple as there's probably something to adapt what you have and apply it to it. Maybe that's not the best design ultimately, but how do you think about that as you interact with like practitioners, deployers, in guiding them? And by the way, and mea culpa, we definitely encourage questions and comments from the audience here. I imagine there's a few folks who've confronted this here. How do you think how do you think about that?
Yeah, I have some opinionated answers here, so let's just hear those first, right? So I've run into a lot of customers that are basically app developers. They just want to deploy a stateful application on Kubernetes. They do not want to become storage admins, right? And that is what a lot of these software-defined kind of run your appliance of Kubernetes style kind of forces you to become, right? And that becomes a big problem because within that organization, there is a storage team that have like rack rows of NetApps and 3PARs and whatnot, right? And they want to leverage their existing investment, right? And it's just like and that is where I focus most of my time. It's just like how do I enable our existing install base to go on this journey to cloud native and using what they already have, right? And then you get the right abstractions. Another thing that is kind of more important if you're running in the public cloud, I guess, is that these software-defined storage appliances that you can deploy on Kubernetes, right? They consume resources from your cloud, right? So all of a sudden, you need to have more CPU and more memory because all of a sudden your data dropped into your compute, right? And so if you turn on like deduplication, compression, encryption, it's just like where are those CPU cycles going to go? And where
no free lunch.
There's no free lunch, exactly, right? Where if you have an enterprise storage array on the floor that does that out of the box and all does is chew electricity. That's the cheaper option for private cloud, at least. Right?
So certainly, if there's any other perspective on the panel, but likewise, love to hear from folks here in the audience. How have you thought about that? Did you start down the path of adapting existing infra, or have you determined maybe after the fact, sort of bespoke, net new, clean sheet is the right approach? I know I see some guys over there wearing NetApp shirts that might have an opinion. But no, not to pick on them. Go ahead.
I was just going to say, going back to what we recommend, I think we see when you're looking at stateful services, it really is, we've talked about skills and missing skills and training and all of that. I think the focus needs to be on using what's out there in the community, use operators, use managed services. There's solutions out there for everything. Start there, and then change or innovate if you need to. So I think that's kind of what our recommendation is always there. If you're going into an environment, any infrastructure now, any Kubernetes infrastructure will come with X, Y, Z networking, compute, storage. Start there, and then decide what you need to go.
So on that clean sheet, that sort of imaginary clean sheet, it seems like people design things differently from an organizational perspective. And most large entities still have the notion of a storage team. How do you see this playing out with folks who kind of come with a storage and data management focus, but they're providing it vis-a-vis Kubernetes and other cloud-native capabilities? Or is that, and this is meant to be slightly provocative, an anachronism? Does that sort of wane over time, that sort of organizational model?
So we, at MinIO, what we see is we have an operator. So we allow admins who run their Kubernetes cluster to provision storage with a simple configuration file, a YAML file. And what we found is there is still currently a need for someone to make decisions at the hardware level, the infrastructure level. And we're continually working on getting rid of that, abstracting it, such that depending on, say, the need of an application, storage is provisioned on demand, or hardware is provisioned on demand, and then just provided to the application. However, I guess the answer would be eventually we'll get to a point where we can truly abstract the entirety of how we use from the hardware layer to how the application consumes storage. As of right now, though, the decision is there's still a need for that human operator working at the hardware layer or deciding how much of the hardware I'm providing to my storage.
I was just going to agree with that, and also with Mike's point that I think when you're on-prem, there is a storage admin. When you're in the cloud, we don't see storage admins. And yeah.
It all depends on who started the journey, right? Like if it was dev-led, they might have started from the public cloud first. If you look at the CNCF surveys from the past, public clouds obviously had a major share, but now that it's getting mainstream, people are moving back to on-prem. The storage teams are getting involved, and they want to support the developers with the modern apps. So it's not one or the other. It's just a part of the journey. Like, okay, we started somewhere. Now let's see how we can come together as a dev and an ops team and see what's the best way forward for the organization.
Go ahead.
I was just going to add, but what we are seeing, what you didn't ask me was, I think what we are seeing is data management. Those operators, those roles are moving, right? And so now we see infrastructure ops, which responsible for running Kubernetes infrastructure over, whatever compute, storage, networking you've chosen, and data management, data protection is part of the responsibilities of those groups.
So I guess one question with, so you're saying, and maybe this is a suggestion, I think it's probably already set in stone, but maybe a byline for this session is it depends. Yeah, and that makes perfect sense. I mean, it's an adaptable tool, set of tools, This isn't confined to Kubernetes alone. What are some things that are next? What should be the focus of the community? Since we're assembled here at, co-located with KubeCon, we talked about CSI and some evolution. We talked about COSI. But what are the next things that will be most meaningful to help people deploying and consuming sophisticated storage and data management?
One is the simple answer of move the value up the stack. So that would mean provide data management services like encryption, provide some kind of properties of the data, say tag a data as something like PII, personally identifiable information, make sure the compliance rules around it are automatically taken care of. That's one side of things where there needs to be some focus. The other is just dealing with raw scale. Currently, we can manage data up to, I would say, hundreds of petabytes pretty easily, but data is itself growing very fast. The rate of growth is accelerating. So very quickly, we're going to also have to think about how we're going to support larger and larger scales. I would say those are two things.
Go ahead.
To add to his point, it's about abstractions, right? Obviously, Kubernetes now is at a point where it has become the platform where you build and run apps. How else can we abstract things away? So if again, going back to the developer and writing a YAML file, if I can specify additional storage level details inside the YAML as part of my application, I need to protect this application. I need to back it up to an XYZ repo. I need to make sure I have encryption enabled. I need to make sure I have some sort of rules in place that if my persistent volume is running out of capacity, how can it expand automatically if possible? If not, through GitOps workflows. Like bringing higher level abstractions into our usual CI/CD workflows or our development cycles is, I think, the next evolution.
Yeah, there's a lot of bread and butter functions. I would call that they are sort of blatantly missing, right? So where's the snapshots scheduler, right? Why isn't that part of the CSI? Obviously, we can work with K10 for that to get that functionality, but a lot of those things are sort of missing. But another point I want to make as well is that the journey that most customers have been on, like going back and forth public cloud and back to private cloud and such, is that one trend that we're seeing pretty dominantly now is that everyone loves the managed Kubernetes experience, right? And we can see that with all the big three cloud vendors, they have some sort of managed offering. They're bringing that managed offering to on-prem as well, right? And that again solidifies the position for Kubernetes to become the most prominent container orchestrator out there and the most prominent deployment pattern. And at the end of the day, it's just like, how do we make it easy for those app developers to just, yeah, I want storage, here it is. I want a snapshot, here it is. And they shouldn't need to worry about anything, like any vendor, right? And VMware does a fairly good job with what they're doing today with their cloud provider interface and the CSI driver that they have, but they do not have like all the last mile. They're completely missing there, and there are gaps to fill those with K10 for sure, but it needs to be standardized and followed.
I have a narrower view on this, and I really like what's happening in the data protection working group, for example. And what we're observing is the problem of state has been, or storage has been solved. Every storage provider will integrate into Kubernetes. Every data service, Mongo, Cassandra, Postgres, there's a way to deploy it, whether it's managed or inside Kubernetes. There's a way to use it in your application. But now, you don't have one of these in your environments. You will have multiple of these, right? So all of these things need to work well together. And we as a community are getting together. We're looking at what interfaces need to be defined. We've been working in the data protection working group and with people like DataStax and with people like VMware to help define, for example, backup APIs for data services. And so we're trying to push those interfaces there. So if DataStax goes and implements those APIs, it'll work with any data protection vendor out there. And so this is how I think people will be able to run their applications with confidence. They'll be able to say, I'm going to pick this data service because I know it'll work with whichever data protection solution I go pick. So those are the kind of things that I think we need to do more as a community. I think we're doing it.
Yeah, maybe I'll quickly vie for or sort of suggest that an area where I think it could really solve for like really making hybrid work for, there's a variety of different scenarios in which hybrid applies. Sometimes it's about like deployment time choice and not necessarily movement migration, repatriation, et cetera. But in the scenarios where that does apply, what is the standardized way to, like pull that off across varying security models, varying networking models as well, and how do I actually move potentially across heterogeneous storage in an efficient way to make sure that Cloud A workload, hosted workload can then be fully rehydrated in a secure and efficient way in Cloud B, wherever that lives, whoever that provider is, or maybe self-managed.
So you went there. You went to migration. You opened that can of worms.
It's all things storage and data management. I did. How about from the audience?
So I guess that a question from earlier, or a comment too. When I first started doing Kubernetes, I called it the 1-2 punch, CNI and CSI on-prem, because one hits you and the other hits you. The complication, the variants that are out there, and that was one of the biggest challenges. So I eventually started to do Rook, Ceph, and whatnot, but I think as the early conversation had when the fellow was saying, well, no, just don't even bother, go to the cloud, go to AWS, that's the big challenge, because the minute you start to bring this into on-premise, you face this. And even our storage guys were like, whoa, I don't want to learn this. So that's what I'm kind of hoping to hear is it's going to get easier. I mean, even the external snapshotter, I was going for a while not figuring out that it wasn't even loaded, that it wasn't part of the main API until I started to read documentation. So it's a challenge, I think. And
I agree. I think it's absolutely is going to become easier. That is, obviously Kasten does that, other companies do that, but our goal is to move more of this, some of this into kind of the APIs as well, so that what we really want to do is you as a application and infrastructure owner, we want to give you the confidence that if you write your application, you pick a choice, you make a choice, you will still keep that portability promise that Kubernetes made you, even if you have state. And so I think vendors provide that solution today, but it's not consistent across the board, and so I think we're working on that.
Yeah, so talking about object storage and being hybrid cloud, so unlike file and block storage, the API to put data and get data from different object storage systems are not the same. File and block stores use a common API called POSIX, whereas object storage, depending on which backend, which vendor's infrastructure you're running on, you speak a different API. For example, on Amazon, you'll use the S3 API to read and write data. On Google Cloud, it's Google Object Storage API. Same things, similar things exist in Azure and Alibaba Cloud as well. So, and then there is the question of also being compatible with on-prem deployments. That's when what has happened in this space is most vendors and most applications have standardized on S3. So one efficient way to be compatible, be able to be hybrid cloud, is to standardize on the most popular one out there. And on top of that, the cozy work that we're working on, that we're doing, adds functionality where it separates the responsibility of a storage admin from an application developer who's consuming that storage, such that the application developer need not change any configuration, need not change anything that has to do with storage or how they get it in their application definitions, whereas the storage admin, who is responsible for moving data or moving the application from one cloud to another, deals with this issue of changing the vendor in the back end. So by making that distinction, we also we put the responsibility of dealing with different vendors on the admin. We ensure that the risk of getting things wrong is lower, because the developer is not expected to understand the backend infrastructure as much as the admin is.
Thank you. Yeah, just briefly, I'd be remiss if I didn't respond to the gentleman who chimed in. So I think we talked about the storage seg. We talked about the data protection working group. The community absolutely would love to, get more perspective and input from the deployer and operator community. And so we have a ton of expertise as ISVs in solving the problems, but it's so invaluable to get your perspective. It's worth its weight in gold plus to get your direct real world experience injected into how we're framing standards and implementation.
I had a comment on something that came up a little bit earlier about the storage team. I think in a company like ours, I work in a startup, so in a small company, there is no longer a separate storage team. But there is still a product team and an infra team. Because like Bhavin said, the product developers don't really want to have to worry about all things infrastructure. They just want to be able to provision the storage they need to run the application. My question is on persistent volumes versus local disks, SSD, NVMe. The big attraction of the local disks is the performance characteristics. So what does the panel think is left to do in terms of getting persistent volumes closer to the performance characteristics that you would get with local disks?
So that's something MinIO is very close to. This is a problem that MinIO works on, actually, because MinIO itself runs on Kubernetes, and it's a storage software, and it needs raw performance of the disk in order to deal with in order to provide a high-performance system. And what we did is we came up with our own CSI driver called Direct CSI. What we do is we use just local disks for the performance, and for the integrity of data, for the durability of it, we rely on the application that's using the drive. So MinIO itself, our server, uses the drives and provides a storage API on top, and the storage API, because it's able to use the drives locally, it's able to provide high performance. So to answer that question, I guess in order to use, there is a good reason to use local drives directly with Kubernetes, and mostly it has to do with performance. And if you're looking to use something else, something that still provides you high performance, the answer might lie in object storage or storage over the network. And I can go into why object storage is faster, but...
Oh, well, yeah. So I think we're supposed to avoid the cage match portion of this.
So. I need to add one more thing before we move on to the cage match. We don't have to choose one or the other, right? It doesn't have to be persistent volumes or local disks. There is an open source project called Stork, Storage Orchestrator for Kubernetes, and Portworx works with them. It works with your API server to schedule your pods where your volumes are actually residing. So you still have persistent volumes, but locally on the same node. So if you're not using an array, if you have local storage, you can definitely use that and the Kubernetes constructs that come along with it.
Was your question whether you can move away from using local storage in NVMe, or was it how to improve the experience? Oh.
Pretty much the other way.
The first one?
Yes.
Yeah, so just to repeat, I think the answer was, can we move away from NVMe or local volumes, and can we get the same kind of performance from Pvcs? I think the answer is going to be no in certain cases. You will need to, obviously, I think it's going to end up with the physics things that are local, things that have less layers, less abstractions between your application and the bits. There will be some use cases where you just can't avoid that. I think MinIO needs that.
And I'll interject a little bit here as something other than the moderator. I think it's a very complex topic in which you need to essentially profile your workloads to understand the specific characteristics of it. So certainly that's a case often for software-defined storage in that it's co-resident, and so you avoid the round-trip latency of going out across the network, but you lose a lot of things in terms of like resiliency and the actual ability to persist in the event of certain failure scenarios. Likewise, the ability to essentially gang or stripe, if you will, like across a larger number of workers in network storage. So it's just really highly dependent on your workload and characterizing your workload to understand what's best. But going back to that theme I was joking about, there are options. So the question is also, if local storage, can I make sure that affinity, anti-affinity are provided for at time of pod creation to make sure that it's as resident and local to the PV that I care about. There's a lot of work happening there, and you kind of alluded to some of it's happening elsewhere also in the community, but I think the end state here is that because there's so many different workload profiles, there's going to be a lot of different options, and more or less all of them are being provided for. But back to the moderator role.
There's also the other piece which we alluded to, which is when you think about data services, you can have data services that are using local storage, but then give you the properties that you're looking for. They give you that reliability, the durability across like node failures. And I think that's what we're seeing a lot happen also in cloud native. We're seeing a lot more adoption of because it's a distributed system, we're using Kubernetes because we want that reliability, and so we want it from our data services as well.
Yeah, absolutely. Makes sense. I did see a hand raised over there in the dim background. Yeah. It is blinding here.
Okay, is it working? Yeah, I think to Vaibhav's point, right, you can do it multiple ways. I mean, direct data services using native disks. Another way of doing it is distributed block stores. I think, Rob, you're kind of alluding to it, where you stripe and then provide affinity through different ways. And one way of doing it is you're leveraging native RWX, right, your file services, and use that underlying distributed block store where you don't have to compromise or say, I won't use NVMe, but you can build on top of it, right? And there are products which are out there which can do that, bring the best of both worlds, right? This is something you've done with distributed systems with VMs, but natively do it with Kubernetes, providing the flexibility and simplicity, allowing your kube native operators to manage it.
Yeah, you sort of touched, thank you for that. And I think you touched on something, because sometimes people don't equate Kubernetes with simplicity. But keep in mind, some of what we're talking about here is being able to use the same tooling and processes that you're already employing for the rest of Kubernetes. So that's net simpler, if you will. If you were solving that problem in Kubernetes alone, maybe that wouldn't be the simplest approach.
What I also love is a few years ago, we didn't have these options in Kubernetes. A few years ago, if we were sitting here and you asked, okay, what's the way to run X stateful application, there would be one answer. And now, I mean, it just goes to show what's happened in the community, what's happened with the adoption. We have almost everything that you could get elsewhere is there.
Yeah, you mentioned the word stateful. I thought we were going to avoid that. But since you said it, again, it goes back to the theme. Stateful or stateless depends on the workload, depends on the application, depends on the use case. Answer is yes. We don't really care. We have options, and we're going to try and deliver sophisticated experience for data management where stateful.
I think we did say we would avoid that, because I think there's been a big disservice to the community when we start talking about stateless and stateful. I mean, you've got an application that has data. You put it wherever you want. The application needs to work, and then it needs to work in production.
I went there. Mea culpa.
I think there's a certain type of application that is better off stateless, and there are certain types of applications that are better off stateful. For instance, if you have an API server, if you have a web server, a web application, it's better to make it stateless, because you get the benefits of being able to operate on it very easily, scale it up, manage it, and you can rely on you can still store data. You can do it over the network.
Are you suggesting that in some stateless scenarios, in fact, data is actually safely preserved?
That is exactly what I'm suggesting.
Okay. Just want to make sure.
Yeah, and the way to do that is to keep the data over the network and access it from there. And I don't mean distributed or network block devices or network file systems here. I do mean object storage. Yeah.
Really?
Sorry?
Object storage is the answer to everything.
What was the question?
Coming from my perspective, I see solutions here. It certainly is not the answer to everything, but there is a good case to be made here, especially in the Kubernetes world, in the cloud native world, for object storage.
I agree with you. I'm actually, that was only half jokingly, because it is an amazing tool that we now have available. A primitive I wish we had when I was building like software 10 years ago or 12 years ago. So yeah, object storage has a huge part to play in the kind of applications that we're seeing getting built today.
Yeah, especially at scale, as the amount of data increases, it becomes harder and harder to access data locally or even from network devices, because as the amount of data increases, the performance that the local devices can provide is quite constrained to what one node can do. But when you're looking at data over the network, today you can have network bandwidths of about above 100 gigabits, whereas you just cannot get that same thing from local drives. So at a certain scale, object storage starts becoming higher performant or more performant, and that's where we see people adopting object storage with high-scale data.
Yeah, aggregate throughput across multiple. Yeah, sorry, I guess maybe this is no longer working, but I'll just speak up. Agreed. I think another theme here is yes. Oh, okay. So I will take this. Thank you very much. So what I was going to say is back to the prevailing theme. We've got options. We're represented here, but across the broader community. Kubernetes, cloud native, allows you to get it done. The question is, making the right choices along the path. I'm not sure where we're at and from a time check perspective, but if there's any other questions, I think we have time from the audience. Sir, the fellow in the front row.
Then what about what you were saying earlier about data persistence and how the people here at a conference like this, often the developers, are just more interested in using Postgres?
Well, something lies behind Postgres, but I'll let the other folks answer that.
Yeah, Postgres is a SQL database that requires persistence.
But you're noting earlier the differences between the different storage capabilities. But when it came to developers, they don't really care about the storage.
That's certainly true. Yeah, and that may be the case, and that will probably be increasingly the case, that you would care about the effect. You want an abstraction that gives you the quality you need, and you don't want to know about the details. You want it to be more or less opaque. I'm not a storage admin, I don't want to be a storage admin, that type of thing. But at the end of the day, Postgres doesn't exist magically without something underpinning it to provide the qualities it needs to deliver a Postgres service, for example. Sorry, my opinion. Back to the panel.
It's about abstracting it away, right? It's not just going to be Postgres. It's also going to be 10 different data services.
Right.
And as a developer, I need a platform. I need a managed service that can just do the work for me, deploy everything that's needed, like persistent volumes and set up backup jobs, and abstract all of those things away from the actual task and just give me an endpoint that I can work with. Same goes for streaming and search.
Then why aren't you talking more about that than just all the guts underneath? Is that because of the audience here, or is it just because of your interest? Or I'm just trying to understand why we're talking so much about really the plumbing here, when really it's what the people care about is the abstractions themselves.
No, I think it's a great point, and actually that's one of the things I was mentioning, which is you talk to developers, they often are not worried about what storage is. They're worried about what the data service is, and sometimes even higher level. And That's where we're seeing a lot of stuff happening in the community. That's where we're getting API standardization. And that is what is driving adoption of state in these environments.
Yeah, querying, analytics, search. Yeah, these are the things that drive or that the developers actually care about. Yeah, that's basically it.
Next year, this talk should be like data storage and applications instead of just data and storage.
Yeah, I kind of want to piggyback on that because I'm in a project right now where it's heavily focused on a particular NoSQL database, right? And when you get onto the application abstractions, you absolutely need an application expert to understand the constructs that particular database need to persist storage, to protect data, maintain resiliency for all the different replication controllers that are available in Kubernetes, right? And somehow that kind of falls like one level above my head in a certain way, but we have really good discussions on what that particular database needs from a resilience perspective, protection, performance, like the whole gamut, right? And we can tailor that to a particular performance envelope and capacity and expansion and all those things. But the application expert, he needs to be in the room, right? And that would be the guy for that particular NoSQL database.
I guess we're still at the point where we're abstracting the lower level concerns, and we haven't gotten there yet, where we're dealing with things like abstracting away analytics, where you just say, hey, I want some analytics engine behind this data that I'm storing, without knowing what it is. So yeah, that's where we are right now. But yeah, like Michael was saying earlier, next year it'll be more about those higher order services, hopefully.
I would attend that panel.
Yeah, I think that I'm kind of new to this, to these discussions of storage. But as a user, a consumer of storage, I think that Kubernetes might be better off if we stick with simpler abstractions as opposed to having abstractions which recapitulate all the capabilities of the underlying storage. I mean, in the end, if you really care about those capabilities, and I'll just give you an example, long distance disk replication, synchronous replication of disks, you're going to have to go to the hardware to figure out whether it's going to work or not, because you have to have like matching firmware in different locations, stuff like that. I think what's a concern for me is, can I get different classes of storage? Like, can I get high performance storage? Can I get, network attached storage? And can I control, sort of general properties of it? Like, what's my storage bandwidth? Something like that. If I can get that, as far as putting it together and making it work, I do that at the application level. And I think that's the overwhelming trend you see with systems. And I'll just pick Postgres, which we used as an example. Nobody in their right minds uses underlying storage, or at least not anymore, to protect Postgres. It's done in Postgres itself with streaming replication, for example, or what Amazon has done with Aurora, where they just rebuilt the database so that it kind of, so that part of it was well integrated with the storage that they were using. This is solved by the application, and I think what Kubernetes needs to do is just give us really clear primitives that you understand what it is you're getting, like quality of service. Just a comment.
Yeah, I 100% agree with that. Simple, clean abstractions are better for composing more complicated or more higher order functional services on top of. I guess what I meant by things that we'll focus on in the future is doing the same thing, higher order or simple, clean abstractions for things like replicated storage across the internet, and that would be something that operators would solve or vendors would solve with their storage platforms. Another chance for me to talk about MinIO here and object storage, but we do that. We give you the ability to deploy in an abstracted fashion, deploy replicated object storage across the internet. Just with a single YAML, you could just provision it, and as far as an admin is concerned, it's just one YAML, and as far as developer is concerned, it's object storage.
Just brief administrative, and thank you for that. And I'm not sure if this is actually working yet, but I think we may have to wrap up soon. So final comments, if you wouldn't mind.
Yeah, I don't really have anything to wrap up with. I just want to thank everyone for coming out, and it's been great being part of the panel. Thank you, Rob.
Thank you.
Yeah, thank you, everyone. Thank you for this opportunity, and it was nice meeting all of you. This is my first time, after a long time, coming out here, meeting people in person for a conference. Appreciate that.
Yeah, we are still figuring out whether we fist bump or handshake or like hug. So we're getting there.
I think it's a group hug right now. I think it's how it's supposed to go.
Head bump.
We're already sharing mics, and it's all done. Thank you, everyone. Really good to be here. I think point taken about what you said, and I think that's what people are trying to do. They're trying to say, don't put too much stuff into the interfaces that we have, but maybe create different interfaces if you need them. Don't destroy portability, but I will leave it there.
Yeah, agreed. Thank you very much. I want to thank everyone here and online. Take a look at PV storage classes. It more or less describes what you're talking about. And I'll hand it off to this gentleman here.
Thank you, Rob.
Thanks, everyone.
Okay.
Thank you.
Wait, was that a yes for the group hug? Or are we?